my name is Blake Sanis with RMS Roller-Grinder. I'm the Vice President of Sales.
And I'm Josh, and I'm with our Research and Development Department here at RMS.
So today we're going to talk about the most common failure that we see on roller mills, the reasons why those failures most often happen, and ways operators and customers can prevent some of those failures, and also some ways that they can maybe automate it. So Josh, with you being in the research and development side for RMS and having a lot of field experience with this, with roller mills in general, what is the most common component that you see failures on?
The most common component to fail is our bearings, and it's also the most common reason we have to go to a facility outside of having to do the normal maintenance of sharpening rolls.
Okay, and in your experience, why does a bearing tend to fail?
Bearings tend to fail because of three main principles, and it's called the lick principles. It's lubrication, installation, and contamination.
Okay.
These things are extremely preventable, and that's probably the best part about it.
Okay. So break down the lick principle when you say the lubrication, installation, contamination. Just give us a high-level view of what that is.
Sure. So let's start from the first step is installation. So
Okay.
if a bearing's not installed properly, it's not seated properly, it's not concentric, it's not going to run balanced, it's not going to run tight to the shaft like it's supposed to.
Okay.
So it's important to make sure that from the get-go, it's on the bearing or on the shaft and on the frame correctly.
Okay.
Contamination is making sure that materials outside the bearing that aren't supposed to be in there aren't getting ingress into the bearing.
Okay.
So making sure that, say, corn dust is not getting into the actual grinding or the rolling area of the bearing.
Okay.
And lubrication is commonly misunderstood by a lot of people. They think that a grease is a grease.
Yep.
And that's not necessarily true. So a grease meant for one part of your plant versus a grease meant for another part of your plant are not necessarily the same thickener, and they're not compatible. And if you mix those two, it could turn into more like a clay or like a bubble gum, and no longer is very lubrication-like.
Okay. Interesting. So obviously, if customers have really good greasing schedules and everything like that, they're still prone to failures, just like all of us. What are some ways that they may be able to automate the process and kind of help with the lick principle that you described?
Absolutely. An automatic greasing system is a really good way to make your greasing consistent and make sure that people from different shifts are doing it the same way. And we all know that the reality is during our day we get very busy.
Yep.
And say there's an emergency in another part of your facility. You're going to get distracted. You're going to go work on it. Oh, and now I forgot. I didn't get my lunch break. So now I'm going to go on my lunch break. And suddenly it's time to go home and you forgot to grease your machine.
Yep.
So how do we prevent that? Let's automate it. Let's make sure that an automatic greasing system is putting the correct amount of grease, the right type of grease in there on a regular basis.
Gotcha. And another component that I hear you guys talk a lot about is also what's known as a bearing monitoring system. Tell us a little bit about that and why that can be beneficial for customers.
Absolutely. So this bearing monitoring system, what it does is it takes a temperature reading from on the inside of the bearing by the inner race.
Okay.
And what it does is it measures that temperature and can trend it out for up to 30 days. You can see how much that temperature is fluctuating in temperature. But if it reaches a certain level, it'll actually send out an SMS text message or an email alert to you or your team and also to RMS, letting you know that that bearing is getting hot. Okay. In which case you want to take action to make sure that it doesn't get too hot. However, we have another feature built in that is if it gets too hot, it'll prevent a catastrophic failure by shutting the machine off at a certain temperature.
Interesting. Well, there you have it, folks. Josh just explained to us what the most common failure is, which is on the bearings, is where we see most of the failures. Ways or why those bearings fails, which is oftentimes an issue with the lick principle, lubrication, installation, contamination, and maybe some ways to automate it. If you got any more questions, feel free to reach out to us at 605-368-9007 or visit our website. You can find a little bit more about it on there. Or just give us a call. It's the best way to do that. Thanks. Have a good day.